Hello everybody, welcome to another stream. How are we doing? So, last stream was pretty cool. But did I post it live? No, let's do that now. Right. So last stream was pretty cool because we got the we got the new tile binning stuff in. So now our spheres are sorted front to back, and we can do alpha blending and anti-aliasing, which we got done last stream. So wait a minute, where did I do this? I put it somewhere. Yes. We should delete some of this old code, not gonna lie. Alright, let's just re-enable that. This is broadband. Right, I'm gonna add first. Right. Okay, here we go. Right. So behind these tiles are the spheres. Let me just re-enable that. There's a if to do with the there we go. So we commented out the LOD stuff. Then now let's disable the draw 2D rendering that we're getting. That ABB, there we go. Yeah, this is what we were working last stream, basically this. So all these spheres here, there's probably over 1 million of them. Yeah, we get some glitches still when the clusters go near the edge of the screen. There's about 1 million of them that get rendered and they get occlusion cold and stuff. They're also anti-aliased as well, so they don't have any sharp edges, which is kind of nice. Which we can view. Well, let's do a bigger box. Right. So we see here at the edge they'll get anti-aliased, and also obviously with each other they get anti-aliased. And we also have transparency support as well, but I haven't tested it out. But it should just work the same as the anti-aliasing basically, because that's how it works. When it ray traces, it sees how far it missed the sphere and then changes the opacity. It's quite cool. Here's looking a bit funny because it thinks the background's black, so it's blending with black, but we've got this pink background. Yeah. Yeah, so that's really nice. Hey there, Nico, how's it going? How you doing? So, let me quickly just commit that and say, well, I might rewrite history. But let me push that up with a force. Bad idea, but let's do it. I think there might be a git tag. Oh no! What have I done? It's protected, damn it. Oh shoot. How do I fix this? Rerun history was a bad idea. I'll change my settings in the GitLab, I reckon. It's a protected branch. Let me go and sort that out. Right, I need to go to the secret screen, but I'll still be here. Bum, 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 bum. So I'm just going to go ahead and log in. Because I don't have a... where am I going to? Where's the GitLab password? Yeah. That's the email, that's the password. And verify I'm a human being. Verification code to my email. There's so many steps. Doing pretty well, however, I do have a question. My sanity in building cross GCC from previous BSD ARM64 to NetBSD Spark 64. Right, here we go. Can I change the how do I change the protectedness of this branch? I think I can share my screen now. Wait, let me close my password manager. I'm back. Right, so here's my super secret project. There's like a protected thing somewhere, right? GitLab protected branch. How do you change that? A maintainer role? I thought I was a maintainer. It's me. Can I get some settings or something? Me, the member. I know a maintainer or something. I don't know exactly. Maintainer, so what's going on? How do we make a non-protected branch? Right, here we go. Maybe I can unprotect it. Settings, repo. Here we go. Ding. That's the button I was missing. Right now I can correct my mistake. Eh. And there we go. Fantastic. Well, that was annoying. But yeah, so today what we're going to do is we're going to fix some bugs and then improve performance. So right now there's a bug. Let's revert some of these things we just uncommented. So we're going to disable the ray tracing now. So basically, right, here's where our spheres are. But if we turn the camera 180, we get glitches like this. So if this goes behind the camera, it shows up still. That's wrong. So what I want to fix is a couple of things. I want to fix, like, because this will crash the GPU if the spheres actually render. But I've disabled that. So what I want to do is make it so if there's some invalid data happening, don't render anything. I need to do that first, and then we'll fix the actual bug. So let's take a look into so what is, I guess we've got to figure out like what is happening to this tiles that get binned. What is the data that gets put in here that can cause a crash? It could be the fact that it gets filled. It gets completely filled up with. Let's see what it's binning. No, because if it gets filled up, then hmm. So I wonder if the binned indices, if they end up. So I wonder if, so we should enable this to run, right? And we should kind of make it go and we should say we should make it go blue if the star is greater than the end, if that's ever the case. I want to see that, and we should probably disable the other draw, 2D debug draw. I need to enable the sphere ray tracer again. Right, so the screen doesn't go blue. Okay, the screen's definitely not going blue. So I guess the invalidness could be coming from the invalidness could be coming from the actual data. Like, so imagine we should probably take this and then say if the sphere that we're going to render they can't be put in, yeah, maybe we should say if this is greater than the number of spheres. So the bug could be coming from indexing this array. This array is probably okay. I don't know if it gets filled up though, to be honest. Maybe we can increase the LED. Thing that we did. So in the prepared clusters, we'll bring back more spheres. And let's see what sort of thing we get here. Does it... Ah, we're getting some blues now. So this is where the start index ends up being greater than the end index. So I think what we're doing is we're overflowing. We're overflowing the... Are we getting the fact that the... here we go. We're sorting probably 5 million objects, right? So that's where probably the issue is coming from. So what we should probably do is say, in those arrays where we do the inserts, then into I'm gonna keep that around actually. In the arrays here, so when we prepare the spheres, so it goes over every sphere within a cluster, and it's going to go ahead and fit into the screen tiles. It adds into this array here. Well, we need two guards actually. We need to say firstly, if so we want to be able to say if spheres start index plus spheres to add count, or maybe is greater than the number of spheres that's in this buffer. I think that's spheres cap. I think it is. So if it's greater than that, then what we want to do is you need to kind of stop. We need to sort of like probably reduce this number. We need to put that number back to that or something. And then we'll probably do another check here to say if what's that? It's at the cluster level maybe. So maybe the cluster could just check it once rather than all this complicated code. It could just say, hey, hang on a minute, if the spheres that we are about to add, you wouldn't even know. You gotta load it still. So I guess we could just say, yeah, just tell it to bail, all of them to bail. So if any of these spheres that we're about to add go over the end of the array, just bail. So that stops us from inserting too many into there. Now another problem where we're inserting into this tiled bin, these tile binned entries. So we'll put in multiple of these for each sphere, one for each tile that the sphere goes over. So this array can fill up as well. So I think if we encounter that problem, then We might as well just bail again, I think, the whole time. So maybe we'll do a similar thing like this. Um, yeah, it's somewhere here, isn't it? Then store into their sphere's cap. Now I think sphere's cap, mind you, is like 2 million. We should put that to like 1 million. No, we got like a yeah, we'll do that. Do a million. So that should stop us from filling up those arrays now. So we can test that out. Yeah, it's initially with sphere's cap as the capacity. That's cool. So we shouldn't see any blue on the screen show up anymore when we rotate the camera around, right? Yeah, so we're not filling... Oh, wait a minute, we disabled the... Let's go back to that if spheres count thing. Here we go, so when we... Oh, okay, this is doing all of the clusters. That's fine then. Right. So yeah, we're not getting the glitch anymore, which is great. So we're still got to fix the other glitch. If we find the... Then we'll keep that still. Oh yeah, I want to enable that. So if we enable the draw 2D, so this is for every, when you render a sphere, or when you've selected a sphere to render, you're going to put it onto this array, and then we're just going to draw the tile which that sphere is gone into, basically. So we're going to see a nice lovely tile pattern where the spheres are supposed to be. So if we turn it around 180, we get a bit of a bug. Fills up the whole screen. And this is because this green box here, this screen ABB gets made if the camera is back to front also, right? So this is actually, this is behind the camera, but we're seeing it in front of the camera, and that's a bug. So we need to correct that. The way that green box is being formed around, it's the same code. It's the green box that's made for the clusters, and also these screen ABB boxes get made for everything, spheres and clusters. So the code is somewhere near here. So we could do some... I don't know, we're not really done any frustum culling yet, either. Yeah. Since we just got a single object. But basically we want to do some form of culling. Maybe we just add frustum culling. Hmm. I guess in view space, right? If your view space position, wherever that is here, right? So we'll just say if so we say that if the view space position is behind the near plane, then but that's the center position. Um, we can set them to like infinity or something, and then I guess that solves the problem. They're now off the screen. So half dim. Yeah, so we just say something like if center position in view space dot z plus half dim z in view space. If that is less than the near plane, where do I get that? Yeah, near plane distance, that's our boy. Then we're clipped. So we'll just basically return some form of version of this, which will be like probably just a bunch of zeros. Maybe do some minus ones. A couple of minus ones. Because how does that code get used again? To do screen bounds, then we basically check if it's occluded. Right, 1 minute and max it. I guess there's a lot of code you can skip if it's off the screen as well. We need to do better. We need to do the frustum culling basically. As soon as. But we'll do that later. But yeah, this is all safety checked. Hey VMT, how's it going? How you been? Yeah, not bad, not bad. Thank you. Just realised. Okay, my baby monitor's here. It's good. Yes, Nico's here too. Right, so we turn the screen 180 now. It's still buggering us up. At least on that front. Okay, the 108, when it doesn't successfully go behind the camera, but it still manages to do something really weird. Right. I think we need some proper frustum culling, I guess. Because the problem is when it gets like... So I can probably draw this out. So what it appears to be doing is... Right, something like this. So you got the camera. There's your near plane. So originally it's like here. But as we rotate the camera around that way, this becomes like here. And at this point, it begins to sort of, for some reason, stretch all in front of this. It probably gets stretched infinitely or something, I don't know. But yeah, when it goes behind the camera, it's fine. But at that point, it really messes up. Yeah, we're probably dividing by... I don't know. We're dividing the Z, aren't we, maybe? Maybe we're dividing by the Z. Something weird goes on. But yeah, I guess that's a non-problem if we don't get any crashing anymore. We can fix that later on. So let's re-enable the... let's disable that draw 2D stuff. So those tiles are now gone away. Then let's re-enable the... Oh, the ray tracer's already enabled. It's fine, the crash as long as your GPU doesn't burn. Yeah, but then the stream dies. I'm not doing bad, Duru. How you doing? How are you doing? Ah, where's my spheres? Where are my spheres? Oh, yeah, we changed that shader. Put a return in. Alright, so I think we won't get a crash anymore. Damn it, why am I only seeing 2 spheres? Or what, 8 spheres, right? I thought we did that. Ah, okay, we didn't re-enable the higher levels of detail. Right, here we go. So here's our lovely anti-alias spheres. There's about 1 million of them. We really see like a grid though. Can you see that grid? That's the screen tiles. Like, wait, let me do my CSI enhance. So, tiles, you can see them. That's a bit of a thick brush. Why? So, why can you see the tiles? Like the spheres? Huh? Yeah, true tile renderer. Yeah. Good to see exactly how it works. Awesome. Doom scrolling. Yeah, it happens. Especially like since Elon Musk took over Twitter, it's very easy to because they just like they changed the default viewing mode. So you just sort of like get endless content now. Pretty nuts. But yeah, tiles. There's like a line as well that goes across there. We're not doing anything with neighbors, right? So each tile should be each pixel. Used. Right, let's get in there. Let's see if the glitch is fixed. Right, no GPU crash. We're doing good. Right. So I don't see the tiles here, but as they get small, it's like here's the tiles. Uh you know what it could be? The array gets no. It's just so weird. It starts showing up there. Yeah, it's a feature, yeah. Tile-based artifacts. Could it be the occluders? No. Yeah, that collision buffer's a bit too good. For crying out loud. What have you done? That's a good effect though, I like that one. When you turn on the reprojection, when you take the depth buffer from the previous frame and use that as the occlusion buffer, and move backwards, it just occludes everything, and it looks really funky. Woo! But yeah, that's something we can look into at some other point. Not fussed about that. Yeah, we're looking at the tiles the tile outlines appear on the screen, so that each sphere gets binned into screen tiles. That's just the way this technique works. And for some reason, when you step far enough away, the spheres, it's as if the ones near the tile edges don't get rendered. Is there anything in the code? Right, so you make this, so when you prepare your spheres, let's have a think about this. So each sphere is probably about less than a pixel, maybe. It could be it, right? Spheres are like sub-pixel at this point. What it could be. So you're missing one and hitting the bottom of another. Yeah, that's what it probably is. Yeah, I think it's that. Oh no, wait, is that London? No, I didn't know. Horse is rampaging you. Nah. In the house as per usual. Interesting. Was it just like random, or was it like part of some strike or something? I don't know. Yeah, I think that's what's happening. Is they get sub-pixel. So I guess this leads us to our LOD selection code. Should we test that out? I want to put a nice slider down where we can select the LODs that we render. I think that'd be a bit fun. So basically in the prepare clusters to render LOD, what we should do is we should add, to do occlusion buffer. It's already done. This is where we do the selection, LOD selection. We go, hey, if the thing has spheres and the height in pixels is less than or equal to this min height, then yeah. Or if it's the last level of detail, then we'll select this cluster to be rendered. So what we should probably do is have this height be configurable. And then this means we can just basically tweak how we can probably see the different levels of details. We could also just have an explicit LOD to render as well. So maybe this one could be called max LOD. Yeah, we probably have these two on things that we can drag around and have a play with, I think. So we'll put it in the globals, and this will be called like cluster LOD, like max LOD. There we go. And we'll just have one called like cluster min height or something like that. Or maybe we should call it LOD selection min height, and the other one should be called cluster LOD selection max LOD. So we're gonna make these two lovelies and put them in the global data structure. So it's just globally accessible to every shader. This is specifically the portion which is uploaded from CPU side, and the rest is GPU only data. So we've got one integer, and then the min height, which is probably a floating point. So CPU side, we can fill these boys and girls in. Just got to find it. Globals. So these be equal to some variables that we'll be making, and we stick a lovely bit of immediate mode UI on that, and get those selectable. So at the top we've got a clue. Fire forces had took off from some cavalry unit. They got frightened of something, ran down the streets. There was some footage though. Cool. Yeah. Hey Hero, how you doing? This is Vulkan ray tracing, or are you doing it yourself on compute? Yeah, compute. Did it myself because the ray tracing APIs are complicated, and also I want to try and do something custom that the ray tracing APIs don't. Yeah, don't have. So that's basically it. It's just far more simpler, and also I just want to learn more about like hardcore compute shader programming and stuff like that. So I'm just doing everything in compute shaders and learning about all that stuff. Yeah, that's what we're doing. So let's use our immediate mode UI. It's got to find where we did it. UI. Oh, we did like a checkbox. No, I wanted. It was a. Oh, here they are. Yeah. So here's some other ones we need to add. We can add some sliders this time. So we're going to cut about 100. 100 was way too much as we saw. So why don't we do 50? Right. So this is going to be. We'll just label it something like. Wait. Slider. We don't have a bit of text for that. Right, we're just gonna have some sliders. Maybe if I need a lot of text with a slider, I can always add that in. But for now, we're just gonna drop some sliders down. A slider for U32. I don't want the one with an explicit ID though. We use the macro one. So we pass in the rectangle and the mutable reference to the value. So we need to make that. Oh, what was it called again? These boys and girls. We need to put them outside the scope just for the minute. Then we need the start and end value and then the style. So the start and end for the LOD is 0, is the first LOD, and then it's data LOD count take 1, that's the max value. Then the other, and we probably want it to default on the max value. Make these boys static. And then we want to LOD selection. We did this sort of like min height thing, min pixel height thing. I did it at 4 pixels because I'm not sure if my spheres are going to have crazy pop in. That's the thing about it. So we'll go into that in a minute. What I mean by that. Let's just get it plugged in and have a bit of a play. So F, and I probably have, so we need some sensible maximum. We could just make it like 512 pixels maybe. Maybe a bit more granular. Probably minimum to be like this, like 4 pixels. Let's do 4. Right, let's move these into more of a global scope so things compile. And voila. Let's have a bit of a play. Oh yeah, oh, you've had the time to write some GeoElements, elements, nice. Oh no. Yeah, I did this, they're up on the VOD channel. Let's go to it briefly so I can talk about it. So, VMT, just see how over-engineered this UI system is. It's great. It's the rendering is over-engineered. It's fun. It's quite fun. So I think right. So after the input stuff, we got straight on UI rendering. And I started off not by doing the UI system. I started off by doing the rendering, and we did it full on like with SDFs. And it's not just rendering like an SDF box or anything. No, it's a very complicated. Essentially, the compute shader is like a virtual machine that takes in SDF instructions. That's the way that I can describe it. So we go to like UI render. Basically, no. I think maybe if we just source UI.h, there's a rendering section. Okay, a draw section. So basically, we have a concept of a shape, and many shapes are in a UI draw command. As the shapes can be individually scaled, rotated, and skewed, right? And the commands can be individually scaled, rotated, and skewed. So you've got all these transforms that can happen individually on little shapes that you put down. Furthermore, there's also SDF-based clipping. So there's a whole clipping instruction thing, but we'll skip that because everything applies with the drawing one that I'm about to talk about. So basically, you start your draw command by just saying, I forget now how you start it. I think you just start drawing. You just say, hey, put a circle down, and you put it in command space or whatever, and you sort of put your circle down. You can also like you can prefix these shapes with these transform things, and then you can then say it works like a VM, like a stack-based VM. So you can say, hey, put a box down, put a circle down, and then you can say do a subtraction, and then it will subtract the circle from the box. And then you can you can keep doing this. It's like a stack-based VM, and then you can basically color the final thing in, and then do a finish. And it's bonkers. It's super flexible. It's not the best performance, but it's still, if you want to just render UI, you can render it at hundreds of frames a second. On the Intel box, it's not too great. But yeah, I just wanted to see how crazy flexible you can make something like this, basically. I did performance optimize it quite a bit. So we basically got some form of like VM basically and some distance stack and push and pop off the stack, and it's pretty nuts, but it's cool. So we did that first, and then I made that, and then I did the immediate mode UI. Yeah, so as you can guess, it's a tile-based renderer and Mickey Mouse. Mickey Mouse got, so this is Mickey Mouse based clipping. So it's just showing you can clip the whole screen with whatever SDF shapes you want. Yeah, it's a bit bonkers. And then I did the immediate mode UI a bit, and that didn't take too long. It's quite good. Yeah, and then since then I've been doing sphere ray tracing apparently. So it's been probably I've actually spent more time doing sphere ray tracing than I have anything else. Half the thing has been on sphere ray tracing. Yes, that's how long we've been doing it. It's been good though. Very barren. Hmm? Also, I really have to go through these. I don't know. Yeah, VOD channel. Yeah. Oh, right, with the main channel. Yeah, not bad a chance to do vlogs because they take time. But what I want to get to is I want to get to the point where at the end of the stream I just go over and say, hey, this is what I've done, and then talk about that, and then upload that as a short digest, and then people can dig into the stream if they want. But I also feel like I need to do a bit of catch up. So I kind of want to do the catch up first, but then I don't know if I'll ever get to doing the catch up because I got things to do at the weekends at the moment. I got this wardrobe to still finish up and build. It's half built. It's standing. I just need to put the doors on and stuff. But yeah, things are a bit busy at the moment. Oh wait, we should be getting this UI in a minute. But yeah, I wanna. That's where I want to get to. Something that's a little bit not high friction to get something out. Awesome. Yeah, that's another problem as well with visibility. Yeah, they're there. Actually, my VOD channel's got more subscribers than my Holy moly! I got two sliders on top of each other. 2 seconds. Yeah, my VOD channel's got more subs than my main channel because I've not been doing the subs for the devlogs for so long. I'm gonna do another cut. I've actually got a PowerPoint of that UI thing, and I want to do it, but I've just not got the time. As you can tell, I've tried to do more, but I've gone and actually done a whole presentation on how I did this. Oh yeah, and then I said like, hey, here's some stuff that I've done. You can go look at those VODs if you want, and then like basically going over how the API works. But I've just not got the chance to sit down and just do it. Oh, there's a bit at the end I want to finish on it. But yeah, gonna talk about how it's architected and everything. Blah 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 blah. But I've just not done it. That'd be cool. Right, we've got two sliders now. What do sliders do? Good question. The slider. You know, I could just put the name next to it. So you make a B rectangle, cut left. We'll say, hey, this one gets 200, cut. It's the B rectangle, puts a bit of text in there, a bit of C text. And the text is going to be max LOD. And do the same thing again. Should probably put a bit of spacing there so it's a bit more legible. Right, I don't know how that'll work out, but it should be fine, right? No. Yeah, it's close. It's close, right? This needs to probably be like the rest of the screen. You could just use the A box here. That's what you do. Because it would have cut the remains into the A box. Disrupt and say hi already, but have been a really long day. Have to hit the sack. No worries, VMT. Good to see you. Thank you for popping by. Have a good rest. I'll see you in a future one. Right, here we go. So we've got, for some reason they got like a border style on it. But anyway, they got like a max LOD and then a pixel height. There could be a way to do like an empty style though. I can't be bothered too much. Let's just increase the let's double it to like 400. And away we go. Okay. So here's our LED. we get to have a bit of fun with LED stuff now. So see this grid that we're seeing? I think this is because the spheres are sub-pixel. So the ray is missing. The ray is actually missing some of the spheres. Is it really that? I don't know. And you're getting the bottom of another one. But surely you'd see that everywhere else. Why would you see at the edge of the tile? That's very weird. But anyway, let's play this LED stuff for a bit. So here's our LEDs. There's LED 0, 1, 2, 3, 4, 5. So like that's so that's making everything be that. Now this other one is going to make it based on some form of height, basically. So you'll see it's not. You'll get it. What you'll be seeing is it based on the height in the cluster's height on screen. Hey there, Rizoma. How's it going? So based on the height on screen, you're going to see it change. And obviously that's not a good one because it's too obvious, right? That the LED is changing. So I wonder maybe if we could have something like this. And maybe you just render 2 LEDs at the same time and you just sort of fade one in and out with alpha blending. Because we can do that. But then you're rendering probably more spheres, so I don't know. And I think you're just going to see it regardless, which really sucks. But we're not seeing the tiles show up anymore. When they're big like this, right? I wonder what it will look like with proper lighting, though. Because we don't really have proper lighting, but what we do have is... So let's put it to some extent. I don't really see a number here. We should probably put the number in here. Because that's not really nice, is it? So we should probably put... oh, for crying out loud. I need a... Does it... Oh, it's all done in place. Let's call it buff. Good old buff. Here to save the day. So you like sn printf into buff. Buff, size of buff. And then you'll put your max LOD and then a number. And then you put the LOD in there. Right. Obviously it'd be off by a frame, but it doesn't matter. You put the thing in there. And we'll do it again, this time with right, so try that out. We should see something. Yeah, again, we didn't have enough room, so I guess we put 500 instead. Pixels instead there. We should have a little bit more room. There we go. That's good. Wait, why is it a float? Yeah. Why does it need to be a float? That's a good question. Yeah, because that'd just be a UN. Why did I think it would be a float? What a wally. Right, so we just change that to something a little bit more sensible. Okay. So this is the min high of a cluster before it has to be, before it, for when it will select the LOD. So when it gets small on that, it will select it. So if we put it to 12, what happens? We still see those lines. So how do we change it so we don't see those grid lines? You still see it there as well. So that's a bit weird. So maybe we do like... So I don't think this is probably because the LOD or anything like that. It's something else that we need to fix the problem. But you still see the changes there, right? The LOD change. It grows over like... Yeah. So we was doing 4. I wonder if you see it at 8. So that means you've got 2 pixels per sphere before you see the change. So maybe you don't, right? I don't see anything. I think I saw it slightly there. But yeah, don't really see anything there. Yeah, I saw it just happen there. The way you can tell if you just pause it there and change this LED, you see it pop there. Right. So it's about to pop. Yeah, it just slowly grows on it though. Yeah, maybe it's noticeable, but maybe 8 pixels is fine. Yeah, we still see that sort of tile imprint. Okay, wasted 2.5 hours being confused about why the game was slow because integrating velocity is a legacy way in the game while changing movement mode. I'm not sure what you mean by that. So in the physics, when you integrate velocity in the legacy way in the game. Ah, I see, you're right. Hmm. Yeah. It's alright. I wasn't aware of it. There's so many things to learn in this life. It's okay. You can be dumb and get smart at that thing. Plenty of stuff to be wrong about. Yeah, so I think we can probably get away with like probably a 6, probably a 6. But I want to solve that problem better in the future. Maybe we can have like as I was saying, we can have stuff fade in and out. But then you're rendering maybe twice the amount of spheres, so I don't know. Well, not really twice, but yes, I'm a bit questionable about that. So we'll start off at 6. Um, I don't know if I want to keep this, but yeah, 6. Cool. So why then at the edge of the clusters do you see that sort of outline? Is it because the way the spheres get binned into the tiles, or is there some form of like is the way it's calculating the okay, so what we should really do is we should follow yes. We should make it so that we only see one sphere. Sorry. The first LOD and see maybe the first 8 spheres. And see their bounding boxes. So the way we can do that is we do something like this. And then we can, so this means it always will add that. The first cluster of spheres, it's going to add it to render, not do the children. Then the other thing we need to do is render inside this, calculate the outer screen bounds of a bounding box. Here we have this if statement where we say, hey, render. We are debug drawing a whole ton of stuff, and you've been seeing this in the. This is what's drawing the outline. Sorry, the bounding boxes around the whole instance. This is the code that's doing it. So it's drawing a screen space bounding box and stuff like that. So maybe what we do is we just take that and put it here. That's the 3D one. I want the 2D one. There we go. So let's have a little bit of a look at these things. Why am I seeing like tons of these? Prepare. If the bit set is not set, then return. There should be inactive threads. It was frame dependent before. I mean, it's a fixed time step, but then we render almost sending the values. Yeah. Yeah, like interpolating between them. I get you. Um. Huh? So why are we rendering so many spheres? There shouldn't be 8. I wonder what that issue is. Like, why? Because when you render. So if it's not set, then return. It's definitely not 64 that it's rendering, right? I don't know if I can count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 6. We're about 32 of them. Ish. So there's two wave 32s going through here, but the individual threads are going to become inactive. Could it be clusters? Probably not. It'd only be one cluster being rendered. Like we're seeing the screen position. With that, I wonder if there's anything else that's good to render. I guess we can do this 3D ABB instead for a minute. Right, it's even slower. I couldn't quite get a gist on what. Yeah, it's whether it's. So let's look at the prepare clusters. This one's only is going to render 32 clusters. And so it doesn't do more than. It just does a single cluster, right? I guess we could just debug print it. I'm not sure why I'm trying to reason about it. We can literally just debug print and find out, right? It's very easy. So prepare spheres. Literally, there's this. GPU hpref. Plop that in there, and we'll know exactly what ones we're doing. We should only see 8. But if we're seeing more, curious why we're not seeing more than 8. There's 8. So, what am I witnessing when we go in here? It must be something to do with the clusters then, right? Prepare clusters to render. Let's put a cluster index down. Even more crazy. So, am I... Let's keep those in for a minute. So this only gets called in 2 places, right? One, which is inside this prepare spheres, and the other, which is inside... Oh. Occluders ray tracer. They're the occluders. Okay, I see now. Right, we'll just move it outside the function. It's okay. So the occluders are also using this. Sorry, we'll just move it out. That debug drawing code here, this min max. I want to take that. And where we... This is the sphere, right? I think? Yeah. No. This one's for the sphere. So we're going to draw this, but it's to float cast it. So let's draw that, and now we get to see the bounding boxes. Right, great. So the bit I was a bit confused about is like when they get so small. I think we want to see them maybe at the size of a pixel. They're about 4 pixels there. Right, I'm seeing a big glitch there. Things are not... I can't... Wait, can I do my CSI enhance? Enhance. Not sure if you guys can see this. Can you guys see it zooming in? Is it zoomed in for you guys as well? I guess it's blurry. This is my problem with why I didn't use it. Because they did like a bilinear filter on it. So it kind of sucks. So I got to do a manual CSI enhance. Right, this is better. We can actually see the pixels now. Yeah, stolen. Don't tell them. They'll bust in. Take me out. Yeah, I've been wondering whether I should like because there's a feature that's built into KDE. You literally just press the Windows key and a plus symbol. It's really nice, but it's bilinear filtered and it's terrible, and it's not. It's annoying because look, when you zoom in here, you actually get pixels and you see it. Where if you zoom in like with this, it's just blurry as hell. And I tried to get into their source code. I tried to get into their source code and see if I could find it and make a patch to sort of like change it. Or maybe say, hey, can we have an option here? But I couldn't find it, so I haven't bothered doing it. But yeah, so we're clearly getting the spheres not getting binned into a tile for some reason, right? They're getting clipped here. But the boxes show as if they do overlap, right? So what we're going to do is we're going to follow a single sphere, the journey of a single sphere, and we're going to debug print some more stuff. So we're going to say, hey, for sphere, if your sphere index, I want to figure out which is, wait, do we Yeah. I want to figure out the sphere, like a sphere index. So what spheres what? 25, 6. Right. So I guess it could be probably 29 or 30. What I want. So here's a debug print I made earlier. This is going to show all the tiles. So I want to say if sphere cluster sphere index that's equal to 29. Then do this debug draw. And it's going to debug draw the tiles that it goes into. I don't know that's the one I wanted, not gonna lie. I wanted one of the bottom ones. So is that a zoom? It's sorry, I missed out. I don't know. It's the one that's built into KDE. So you just press the Windows key, but you hold it and you press the plus button and the minus button to control it. It's pretty cool. But I don't know why. Oh, I'm using Linux, okay. Oh, it could be the occluders. No, it's not the occluders. Yeah, it's not the occluders that's causing the problem. But yeah, I want to see. I need to do that damn printing code again. Right, we should get these numbers. These ones. I love how I've labeled this stream doing performance. We haven't even done a performance yet. We've just been fixing little bugs. We should be able to do a little bit today. So let's try 45. Huh? Oh, I didn't compile because I got this damn unsaved buffer in here. Oh, for crying out loud. Right, let's close that. Let's dump that in something over there. I want a low one. Keep picking the wrong ones. Let's do 41 then. Wait. Oh yeah, we didn't fix that bug. Okay, we got a low one. No, it's that back one. So maybe we should pick. Is it just 20? It might be just 25 then. Does make sense actually. We are bottom left origin, so maybe the lower number is the yeah. Okay, we are bottom left origin, so that was correct. Then so it seems like it is that lower left one closest to us. This is the one we want. So it's hard to tell if the glitch occurs, but it's getting binned. Oh, the looks of things into the right tiles. Like we're not seeing that lower left one escape this debug render. But I'm certain that glitch is happening behind it, I just can't see it. was that? It kind of flickered a bit. Maybe it's someone else. Yeah, it seems like it's just going in the tiles fine. There does appear to be this sort of gap, this pixel gap in my debug drawing, but that maybe is to do with the coordinates. When you're using compute, as you were explaining last time, does it still go through some fixed pipeline steps? No. Or does it feel more performing CPU tasks? Also know if you own specific compiler, which makes it even more interesting. Yeah, so basically, like vertex shaders, pixel shaders, every shader is implemented using compute units. And so compute shader is basically a lower level pixel shader without some of the extra stuff that it does. And a vertex shader is a specialized version of a compute shader in a sense, where each thread gets a vertex. Each thread in a wave 32 that runs in lockstep gets a vertex. And in a pixel shader, each pixel gets a thread in a wave 32 that runs in lockstep. And more specifically at 2x2 quads as well. So basically compute shaders are just the lower level version of those things, and they're not specialized for those tasks in any way. If you want to do that, you have to write your own, and you probably won't be as good as you won't be as good as the hardware if you're trying to do the same operations or support the same things as the hardware does. But you can do other things that the hardware is not specifically designed for. And you can do it better using compute. But the problem with compute is you have to be aware of a lot of the low-level workings of the GPU, and things are not always straightforward. But it's good fun. You have to read a lot about how AMD recommends you do things, and NVIDIA recommends you do things. But yeah, so they don't go for the rasterization step. They just literally launch waves of 32 threads that run in lockstep, and you basically get control over running groups of those together and communicating between them and stuff like that. So yeah, they're really interesting. They're great. Can the debug tiles be transparent to see behind them as well? That's a good point. I'm pretty sure they can. I got depth parameter. All this thing on here. So why don't we instead all those bits on, and then we and some of the bits off. So here's me doing a quick hash and oring the alpha bits, and then we're gonna not we'll just keep we'll do some of that. Wait, what am I doing there? I'm removing the high bit. Is that enough? Wait, what am I saying? It's too many bits to remove that, isn't it? Yeah, maybe just remove the top 2 bits. Let's try that. I don't know, maybe I haven't got alpha blending. Let's not make it have any alpha. I think we do something with the alpha. Yeah, let's correct that. Draw 2D render. So we do some SDFs. Some color. Color word. Closest color. So it picks the closest color and it just draws on top. So I guess we can. So it's not going to alpha blend with each other, but we could make it alpha blend with the stuff that's already on screen, maybe. So I did this in the UI. Let me just. So load, blend, put it back. Let's try that. So game color. Right. So we're loading the game color. We convert it back from BGRA to RGBA. Then blend the pixels from front to back. So the unpacked color and game color. Then we convert it into BGRA and then we throw it back out to the screen. Right, let's give that a go. Oh. Oh, it's marked as write only. That's okay. I can amend that. What do we do for the dispatch? Read write please on the surface. That should do it, I think. Hey there, Katsumoy, how's it going? How's everything? Making good progress. Yeah, man, not too bad. Just trying to improve the. There we go. It's transparent now. Isn't that wonderful? Thank you so much for the tip there. Gotta remember your name. Messina. Thank you so much for the tip. Yeah, doing alright. We've fixed some bugs. There's some crashing. We've got had some fun with the levels of detail. Maybe gonna look at performance, like the title says. You know what's quite fun is we actually re-render. We rerun the. What do we do? We're running the volume construction at the same time, so we can disable that. Oh. Right there. Enhance. We're seeing a missing thing. It happens on the actual tile. Like that tile for some reason. Like it must be getting binned into there because it's showing up. So I wonder what it could be. Like it's actually getting to that piece of code and putting it in there. So prepare spheres actually. So it might be the other shaders that come after, then it might be. So we're actually putting it into this array. And putting our entry in there, right? But it's a bit weird how it. I wonder if I can. Is it lining up with this center of the screen or something? What's going on? Like this debug thing that gets drawn, it's not doing. Uh, It's definitely lining up with the tile boundary. Hmm. So it's definitely lining up with the tile boundary and then disappearing. But why? So what we need to do next is we need to put a print statement in where I say, hey, where my mouse is, can I see if... so we've done this before. So I know how to get it to show up again, which is great. But we want to go into the tiled ray tracer. Unfortunately, I've not got that code around anymore, but it's fine. So we want to say if wave is first lane, and our pixel coordinate. Wait, would the first lane matter? Yeah, that's fine. So I only really want a single result. This is what I'm saying. So I might get a couple actually. So I want to say if the current pixel coordinate. No, tile coordinate dot x is less than the mouse position because we put that on the GPU, which is nice. So we do stuff like this. I want to do the keyboard. Just literally upload my keyboard keys to the GPU, but I haven't got around to doing that yet. So I can literally just press buttons and put if statements for that in the shader. Then we want to do another one of those. Probably add this to it as well. dims.x greater than or equal to then finally when you do all of that you can do a lovely print, and what I want to print is like, do I have any spheres here in this tile? And we should be able to clearly see like how many spheres because it's a 2 by 2 by 2 set of spheres. So, and I guess what we really want to do is put it before it ends because I do want to see if it has a 0 value, right? I need to get a drink in a minute. So let's try and see if we get that glitch to happen again. And I could have swore this is... So for those who haven't seen why we're doing this fix, because when we have a screen filled with spheres, we get in... Wait a minute. Here we go. We're getting this sort of tile grid that shows up for some reason. So I was thinking it's because of the LOD thing in it. Something to do with the LOD selection or something. And then now I'm just seeing yeah, then I realized that it's nothing to do with that. It's probably to do with them not getting binned when near the lines. So we started debugging the outlines. The outlines were fine. The boxes are around the spheres. But there's something else which is a little bit wrong. And it's for some reason it's getting binned into the right tile, but as you're seeing, there's cases like that. So I'm hovering over there and I can't see the damn thing. So I'm just gonna... So we should be seeing two, right? There's one behind it. So just hover there. And let's see what we get. No. I'm not seeing anything show up. Let me disable the profiling because it's just in our way. And I can't see like a live thing. Here we go. So we're seeing printing out the terminal now. I'm not seeing anything show up when I put my mouse over it. So there's something wrong with the if statement. Grid dims. No, that's not right. That's the whole screen. Right, see that instead. Still not seeing what we want. Let's remove this wave as first lane thing. Maybe we could be shooting ourselves in the foot with that. I don't think we are. Oh, wait. Man, I'm so silly. This dim is saying the size of a tile in pixels, right? So that needs to be multiplied by that. And then this one also needs to be multiplied by that, but we want to add a cheeky one. So we're saying, where does the next tile start, basically? Yeah, and there we go. So there, we've done our, make sure our mouse is inside the tile, cool. So, let's find that, we're getting those, the full spheres disappearing there, that's weird. Okay, so here's a, good. So we're getting like 8 there for some reason, that one. 0 there, 4 there. So something is definitely up. You can see how there's 4 in this one. 2, 0. 2 there, yeah. 3, 4, 0. They're a little bit too transparent now to see, but I think what you can make out is this is being drawn, this outline for this tile. So it is being binned into the tile. It's just probably the sorting code is a bit wrong. No, so it does the sorting, but then after it, so there should be a before and after that I've done before. Or an after at least. No. So find. So here we basically do the it could be something to do with the end of the array, maybe. No, because then only one of them would be that. So this, after you sort it, it looks over every pair and sees if there's a start to an array for the tiles. So all of the binned entries go into a single array. We sort it based on the tile index and then by the depth of the sphere. So they're all sorted into the binned arrays. So we just try and find the start of those different tile binned arrays. So that's what we're doing here. But maybe, right, so your before entry at least. We know it's going in. It's just whether or not it's, so we should check if it's there after the sort at least. We kind of want to look for cluster. The problem is there'll be a different sphere index every time. So the best we can do is compare a before and after. You'll get 32 that go in. think. So maybe the start indices are not showing up. Could it be anything to do with this fill in the gaps code? So if your entry is U32 max, you keep searching right until you find one which is not, and you take that. And then you copy. Yeah, that's fine. Sphere ray tracer tiles count. What is that about? That's wrong. That wouldn't have been doing it. Hang on a minute. I've only been doing. Oh no, you're going over all the tiles. Oh yeah, that's fine. Yeah, let's print out what the after entry is. I had these here before, but I deleted them. Pair. Do we care about the sphere? I don't really think I can print the sphere. Oh no, I can. I can print the sphere index here. Which means maybe we can do some debugging. Because all we have to do is know which one is 25. What can we do with that? We checks two at a time. I wonder if it's not doing the last one. Yes, if you're the last one in the array, it wouldn't do anything. If you're the last sphere within the binned entries, it's not gonna do anything. What happens if you are a different tile from the one before? Well, the one before would have set your start index. Yeah. So yeah, let's also print out like we'll also print out once so we know that like hey cluster sphere index 25 is sphere this number. So this way we should be able to debug now. We just have to look for that one and then yeah, that should be enough information, I think. Or maybe we need to know this about the start indices. I should have put that waivers first lane back on. There's a lot of garbage. That's fun. Just scroll past it. Just got to find the thing again. Find where the glitch happens. There. Gotcha. Okay, so there's a lot of things. Huh? Right, so clusters is sphere index 0 apparently in this frame. So before the array gets sorted by tile index, sphere index 0 is there one. I don't know what tile I'm looking for actually. I should have printed that out. Maybe let's print that out. Here we'll do that wave is first lane thing, so maybe only get one or two of them. And here we're going to print out the tile index. Um, 2 seconds, I'm just going to run and get a drink because I need one. Nice big water. Yummy. Alright, welcome back everybody. Got myself some water. So we've added that print code. So now we should be able to see the tile index that we hover over and look at that in the output, in the sorted data, in the output data. And we should probably also print out is probably two other values, which I'm not going to name too much. I'm just going to print them out. They're the start index and the end index into the binned entries. So this should be all the information that we need to debug the problem, I think. So let's get the problem to trigger again where we can't see where this gets clipped out or something. There. Perfect. So we're going to hover over that. And then we're going to let go. So for index goes to 2 to 2. So in the array of all of the binned entries that have been sorted, the start and end index for tile 580 is 2, starts at 2 and ends at 2, so there's no entries in there. So if we go up to before it gets sorted, sphere index 25 is sphere 0, right? And what we'll see so let's look to see where sphere 0 is. So sphere 0 is in the before array. It's in there 4 times there, another 4 times, so 8 times. Then afterwards, it's in there 4 plus 4. Good. So that's great. So now let's look for 580, right? There's a 580 there, I see. That's at entry 1, right? So this is after it's been sorted. Bearing in mind that, wait a minute, why are we seeing duplicate entry 1s? That's not good. Ah, shoot, what have we done? The printing code could be a bit off. Uh, oh no, we're seeing it twice anyway, is that right? Entry 16. No, we're not seeing any duplicate. Oh, no. You're not seeing any duplicates here though. Right, something is a bit off there. So we see it printing basically up to 30 in kind of. It's expected to be out of order in some fashion. But then after that, we see it again. And why though are we only seeing 4 entries when entry 19 here is sphere 0, 620, 21, 581, 580. Oh, right, I'm being dumb. I was counting this. Right, so there's only 4 of them. Yeah, and this is just being printed twice. Uh, yeah, I know why it's being printed out twice. That's because I had 2 of them listed here. Because I wanted to catch all the pairs. Now I've just remembered that the function works a bit differently. Find starts. Yeah, so this goes over all the pairs. It goes over 0 and 1, checks to see if there's an edge, if the tile index differs. If so, it has found a start. It says the 0, 1, 1 and 2, 2 and 3, 3 and 4. So it just goes up by 1 but looks at 2 at the same time. So yeah, it didn't used to work that way, so that's why I added another one in. But that's fine. It's just redundant printed information, but we've got all the info here still. So effectively afterwards, for some reason it's saying, right, 580 starts at entry 2, but that's wrong. It actually starts at entry 1. We've got to figure out why. Hey there, Agent. How's it going? Agent Uriel. How you doing? I'm doing. How's Little Henry going? Little Henry's great. At the moment, or now he's asleep. But earlier he was a bit upset. So I had to try and keep him in a happy mood and feed him food. And yeah, but he eventually went to bed. But other than that, he's good. He's just had a bit of an upset evening. But yeah, it's a lot of fun. It's really great a lot of the time, especially during the day. Yeah, it's awesome. I still don't know what it'd be like to have another one though. It's always so uh, still very shocking to me. All of a sudden, it's a baby. But then afterwards, you just get so used to them. They've always been here. Yeah, it's really bizarre for me at least. Like very unknowing what a baby actually will be like. Can't imagine yourself with another one. And they just come. Yeah. And they're also, yeah. Yeah. Right. So what the hell is going on here? Why are we starting? Why is it selecting it? Oh, I know the bug. Do I know the bug? So it's found, it finds an edge. Oh, 580 is the first. Sorry, 580 didn't start at 1, it starts at 0. Okay, so the problem is that tile 580 doesn't have an entry set because it is 0. Yeah, so the first one, like when you find an edge, you'll be like 580 and 581. So you're going to set the start index for 581, but not 580. So, do I want to just say, I could just do it in here, the setup. I think this is the bug. So what I should really do is get the sort key for the first entry. And then be like, oh, this is the tile index for that. And then just set up the start index for that. Tile index equal 0. Boom. That should fix the bug. So I'm going to come out of the printing and just keep it in and not delete it. Then I want to probably go to the tiled spheres one as well. Probably just comment out all of this. And the music has gone. So let's bring that back. Let's give it a Nick Johnson. It's been a while. It's got some new stuff. Let's play some of his new stuff. Let's do it. This guy's the jam. Okay, so right, I did see a bit of a flicker there, but that could have been to do with the occluders, and I did just see something move around. So let me disable the occluders. The low LODs is definitely unfair that they exist. So I'd like to think that we've fixed it. So we shouldn't. What we shouldn't be seeing anymore is this tile pattern. We were seeing this tile pattern when we zoomed out. So I'm hoping that's. No, that's not. Wouldn't be the fix, because you would have the first tile would be missing spheres, and that's always fixed. Oh. So we'll still test it though. But yeah, that was definitely a bug. Oh, what is that? Is that with the occluders? Turn the occluders off and it seems to have stopped that flicker, which is fine. That's what I was expecting anyway. That's fine, that flicker, because it went near the edge of the screen. I know that one. But yeah, I don't see anything, which is a bit of a shame. So you know what? Let's re-enable the sphere ray tracer. Sorry, the cluster LOD selection stuff. Right. What I want now is to see if I can see that tile thing, And if we still do, I think I'm gonna leave it for today. Think about that. Because I'm not really fussed about perfect rendering, to be fair. And we'll see if I can figure it out some other time. We can look at like performance and just look at some numbers. Because that's what the stream title does say. What song is this? Sounds like Nick Johnson. It is. I just put Nick Johnson on. This is latest album came out a month ago. I have not heard it yet. This is the first time my ears have been exploring this one. Nick Johnson's the man. Tried to follow, found what binning is, and didn't know that I was binning stuff in my crappy render instead of actually sorting. So it's binning, bucking stuff. Yeah, so basically binning is just you're putting stuff into different arrays based on some, usually a position. So we're binning, as you can see, the screen tiles. Bum, bum, bum. This is the glitch we tried to fix, but unfortunately we couldn't. So we take our spheres, bum, 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 and we bin these guys into screen tiles. So each screen tile has an array of spheres that it tries to render, basically. And I also inside the inside the tiles they're sorted front to back, so we can render them in order. So we do a full screen pass over a tile. I should get my drawing out. So basically we get all the spheres. They go on the screen. Here's a tile. Here's another tile. Right? At first, we check these spheres and we just chuck them in an array. We go, hey, put this one in an array here. There's another element there, another element there, another element there, yeah? Here's the spheres. We actually have a parallel array next to this, and this has, so this one has the sphere index, so the index to where the sphere is in memory, some other place, right in memory. These are sphere indices. This one has the tile index in the higher bit, tile index in the higher bit, and in the low bit, this is the depth. So there's 20 bits for depth. So then what we do is we have a massive array filled with the tile index in the higher bit and depth in the low bit, and this index matches its sphere index counterpart. And then we sort the two arrays based on the sort keys in this array, and this will then sort them so that all of the ones with with the same tile index will be next to each other, and only ones that are with a smaller tile index will come before, and the ones with a higher tile index will come after. And then within the neighbors who have the same tile index as you, they will be sorted front to back based on the depth they are away from the camera. So this is how the system works that we've designed, basically. Yeah, it seems alright. We're still gotta see if it's like, yeah, there's lots of performance things that we're doing. Like we reproject the depth from the previous frame, which we don't actually reproject yet. So we still get wonderful glitches like this. But yeah, that can be fixed later. We're trying to just see like generally what the performance would be. So here's the occlusion buffer behind us, and we test each cluster and each sphere against this occlusion buffer and see if we can get rid of it if it's occluded. So, but yeah, we basically try and optimize it by reducing the amount of spheres that we bin into screen tiles by getting rid of ones that we don't need to render. We're getting a bit of fighting that's happening here. I don't know what that is either. But yeah. So what we're going to do is re-enable the profiling. And then just get into... Oh, you've been in by depth and doing that. Yeah, make it as transparency. Sweet. Yeah, I do the same thing for the UI code. But I think now I've got the GPU sort, I can probably improve that rendering as well. But doing a similar system is what we've done. So it's written over the profiler. And I also want to disable the... so we build the 3D volume of spheres every frame. And I do that because I want to simply debug. What do I want to do? I want to debug... yeah, I want to make sure it's deterministic, and so if we see anything that moves around, and if it's caused by that, we can fix it basically, because I want the same input to be the same output. So this has been built. We set this to true. It only builds once. So, and it stays persistent in GPU memory. So this will then reduce the frame time because we're not building that every time. Definitely very noisy looking results, I can say that for sure. Sometimes they're 8 milliseconds here, probably because of OBS. About 5. We have got atomics, but we're not doing that many, maybe. So that could be contributing to some of the noise. But yeah, so about 5 milliseconds and 2 here. Define the starts of the arrays. That could be made better, but it's still okay. I know ways we can use wave intrinsics to like share memory to probably make that basically non-existent. So the ones that take the most is basically the tiled ray tracer. I would love to group all this sorting together because yeah, I can't really tell, but the sorting is probably taking quite a lot of time actually. There's a bunch of ones here. If we add these up, it's probably nearly taking a millisecond. Because it's sorting like a million things. Wait, did we have the yeah, we didn't have the reproject depth thing on, so it's not really a fair. We didn't have the proper good occlusion buffer. So that's the reason why the results weren't as impressive as before then. If you have something like that on the screen. There you go. So it's about 4 milliseconds in total. So that's about 1.7 milliseconds for the ray tracer now. And then right, so what we might do is we could put some of this up on the actual screen a bit. We should. It would be nice to look at like numbers. It's like, you know, we're rendering this many thousands of spheres and this many getting occluded. You know, get some metrics. That could be useful. But yeah, the sorting now would end up being less. See, there's not any. They're not taking 0.1 anymore, any of them. So, because we just fed it less data, right? They got occluded and taken out in this prepare stage. So basically what's taking the time here is this tiled ray tracer takes half the time. Then let's see if there's anything else that just stands out. No, I guess it could be the sorting. Although we are still pretty negligible. I guess is that really just all accumulating into another 1 point? Oh no, the debug draws are taking another half a millisecond. So yeah, that's quite good. Should we I guess I could improve the ray tracer some more if I played about with it. I don't know what sort of savings I'll get. But how about we try and add more instances to the screen, right? Why don't we add more instances, right? And just see what we can do. Why don't we just disable this background because it's and maybe the debug rendering as well. For some stuff. Hey there, Just. How's it going? Is this reproject or moving back to screen space to world space? Never did that, just so we're talking about it. Yeah, so when you're reprojecting from the previous frame, here's the problem, right? You got a camera. That's terrible. You got a camera. You got an object. You've got your camera next frame. Right? And say the near plane's there just so it's viewable. So the idea is you've got to map that pixel there to that pixel there, which is this pixel over here, right? So you've got to, and that's what you got to do, right? You've got to move that pixel, that one there, and also adjust the depth. So basically, we're reprojecting a depth buffer. So the way you'd do it is the way you'd basically do it is you would take the screen pixel and take the ray that's going through that pixel. You will use the depth buffer to then put it out to here. So now your pixel now you've got a position in world space. Right, so you move it into world space, you got your position in world space, and then you now what you should probably have is motion vectors as well, because this object could be moving, right? So because this object could be moving, you want to predict where it's going to go. So you have motion vectors per pixel, and you basically say, oh, this is moving that way a bit. So you then move your point a little bit that way, right? And then you bring this back into view space, and then you bring it back into screen space, and then you write your pixel to the new buffer. And that's basically reprojection, right? So you're just seeing where this new pixel goes. Yeah. But we're not doing the reprojection step yet because I haven't bothered. Because it just fixes bugs, and my interest is not fixing bugs at the moment. It's just seeing like generally how good is this system going to be, performance wise. So we're going to add some more instances from the CPU. This is how the system is going to work. The game is going to be like, hey, I got these volumes I want to render, gives them to the GPU. Then the GPU goes and it goes down the tree of clusters and occlusion coils and adds them to the render list if they're the appropriate size. And then, so we're going to go ahead and add another one. We disabled the rotating apparently. I only really have one instance anyway, so I don't know. Yeah, I haven't had fun with the rotating. Should we have a bit of fun with the rotating? Oh, you can get away with simple, slightly wrong. 1 frame of lag situation. Asking for a friend. Yeah, so the more wrong you get, the more wrong you are. So you can do the reproject. So there is a hmm. So there's another rendering technique you can do. Let me see if I can get it. There's a video. Right, so if you're a Gen Z like me, there's a video. No, it was on oh my days, it's like high performance computing 20. I think there's one. Yeah, I think it's here. Man. Um this is it. With the bunnies. Right. So it goes this is where I got the rendering technique from. I think. I think this is it. Where's the occlusion? Yeah, cluster-based culling. Right. So this will tell you a different way of doing it. If you rasterize in triangles, where you can actually use a less right, so I recommend you watching the whole thing from there. Let me get you a time stamped link. Um, yeah, so basically there's a method to do what I'm doing, where you render things, check them against the depth buffer, render a proper depth buffer, and check them again for all the ones that you haven't rendered. That's just a quick way of saying it. And that means you don't have to use a proper precise one, but you can use the imprecise one to help you out and make you draw less. So if you're using like triangles and stuff, then you can do it that way. What else am I saying? Yeah. But yeah, if you only use it once, you have to get it really precise because if not, you're gonna get glitches. Like we. And I can't see this on the screen, damn it. With this rotation. Is it too far away? Oh no, you gotta have scale. Yeah, I don't think the order matters. Small. Whoops, I'm missing the scale. Don't be silly. Too many parameters? Awesome, great. Yeah, you're gonna have to take shortcuts. If you're gonna make something and release something, yeah, you're gonna take shortcuts. Whereas here's me rotating a bunch of spheres apparently bloody fast. But if I zoom out, you basically don't see it. Right. It'd be better if it was a different shape. Yeah, it shows that we can do rotation at least. Anyway, let's comment that back out. Let's do multiple instances. So we're gonna upload another one. I used to have we don't have different volumes at the moment. That's another problem we can solve. So let's do. So we could generate them along a grid. That's another way we can do it. Um, Let's just do a 2x2 grid at the moment. Be a bit of fun. So like an X or Y then X. So I want to say X, Y, probably multiplied by 32. That's the half dimensions, so maybe 64. We'll see. Right. Let's just do 2 at the moment. I don't want to make my computer explode. Let's just gradually go up. Right, there's 2 instances. Rendering. That is going across the Z, the Y though. Maybe we should do the Z. So yeah, now let's up it by. So we've got 4 instances. So here's right. I did say I wanted to get rid of the debug rendering. That's why I went to here. Oh shoot! No, not GF. I already got. Right, there we go. So, what's it like rendering 4 instances? So it's in a lot of holes. So I guess we've filled up some array somewhere. That's kind of like a full screen, like what we're seeing. There's about. Can I trust those numbers exactly? Right, these are the better numbers. Hang on a minute. These are really skewed. What the crap is going on? Why are we getting one frame which is really good? And one frame which is really bad? This can't be because of OBS, right? That's only 2 milliseconds. It's much more of a problem now. And then this one is 3.3. Like, why are the numbers drastically worse? I should really test this off stream, I guess, and see what I'm getting. But okay, so I guess we can up it and just keep having a play. But that's way more than it was before, right? So I guess what's happening, right, is every other frame, OBS is like, hey, I want to render at my 30 FPS frame. And then my frame that I'm trying to render gets starved of compute units, and then it just doesn't get the chance to render as well. So I think that is what's happening, which is kind of a shame. But anyway, so we're getting, it's only about 2 milliseconds, so it lost. What did it do? So we're not doing any UI rendering or debug draw rendering anymore. So that went down, and this went up by about 0.3 ms. So that's not bad. So I think we should just be able to scale this up. Let's do a 3x3, so that's 9. So this is, and I'm seeing this tile effect really bad right now, but this is, how many million? So it's about 1.5 times 9. So it's about 14 million spheres trying to get rendered. But it's not actually trying to render all those 14 million spheres, right? We have clusters of spheres that we cull and stuff like that. So that's about 14 million, I think. Because if you used to make these cubes of spheres, it's 2 million. So they're not cubes, so I'm guessing about 1.6 million, about 1.5 million. So we've got 9 of them. So they're probably about 14 million trying to render there. But the trick is that they're getting occlusion cold. Gotta go. Thanks for the donations. Right, no worries. Have a good night, and yeah, I'll see you in a future one. Rizuma. So where's a good frame? Right, 9 milliseconds, 8 milliseconds, 15 milliseconds. Right, so maybe this is where we reach the tipping point. Right, so something has got slow. So the sphere ray trace is getting filled up with spheres, probably. It would surprise me. How bad's the Right, the prepared spheres is about 0.1 ms. That's probably alright, but it's chucking out a bunch of spheres, maybe. I don't. There's numbers, right? Tile binned entries. We're looking at about 900,000. A million spheres we're trying to actually that we test against. So that we sort. So we're sorting a million spheres in an array, and then we're testing a million in the ray tracing. So I guess the ray tracing is the bottleneck. What's up with these bots? So the one that's taking a long time is this. So another problem with the ray tracer that we've got is that so should we look at the tiled ray, see if there's any obvious performance wins. So per pixel it goes right. I might want to change these. So I think I've got an idea of what a problem is, and maybe we can improve it. So the issue is we've got these tiles. These tiles of 32 by 32 pixels. And apparently what we're doing is we're launching 8 by 8 by 8. Right? So this is just reminiscence of some old design. But I recently upped the size. So if you got 8 by 8 by 8, right, you've actually got, right, and this is not it yet. Yeah. You've got a 4 by 4, right, so 16 different thread groups. Bear in mind each thread group is running an 8 by 4, right? Of threads in lockstep. Because that's 32 threads. But yeah, so we've got 32 by 32, which is 1024 pixels. Split into 8 by 8, sorry, 4 by 4 set of thread groups. So what's happening is each one of these thread groups is possibly getting chucked on a different compute unit. So basically you got a compute unit over here and a compute unit over here. Let's draw a massive wall between them. It's probably got some like cache here, and maybe there's another compute unit over here, and there's like a cache there. Then there's like a big cache here, like an L2 or whatever, these ones. Wait, no, L2 is probably shared across all of them. So it's probably like, I don't know, it really depends on the hardware. Some have 2 and 1 levels, but anyway, the basic idea is these got like an L1 cache here. So if you're each of these runs on a different compute unit, or maybe some of them run on the same. But the idea is, I think they've got to refetch the memory. Maybe from the L2 though. Maybe it's not that bad. But I think it would just be better if they all were one big thread group, and they would execute on the same compute unit. So they would share the same cache. So we're going to do that. Luckily we can do that. So that's 1024 threads. And I just got to make sure. I guess I just changed that number. Good old constants. There's a lot of code I just need to delete. Right. Very good. So we'll try this out. We should improve the performance. Right, so educated guess. Let's give it a go. Alright. Let's get all the balls on the screen. Get to that lovely position. There's a lot of bugs. Was this like that before? Right, so the numbers are definitely less there. But we're obviously... Yes, the numbers are improved, but we're seeing dramatically less spheres showing up here. Like this was 900,000. Like why is there so much culling going on? Did I go like upside down or something like that compared to what we did before? Right. This is interesting. But anyway, let's see the performance and then we'll try and debug what the issue was. It was something like that. Oh. Yeah, so when you get to about 1 million, it flickers like crazy. So we're near 1 million now. Yeah, I don't know if I can judge if we got it better. Maybe a bit better. But yeah. It hasn't got worse. It hasn't got worse at least. Because we were kind of not 900,000 there. Probably give it another. Yeah, that's the one. So the other thing as well, we should be earlying out when we do a test. So each pixel figures out what tile it's in, and then it will see if there are any spheres in there. If there isn't, it earlies out. Then we go over all the spheres. So we grab the sphere to render, and then we grab the sphere to render index, and then we grab the actual sphere. Then we do the ray tracing. Then we do the coloring and the alpha blend. If it's fully opaque, we then break. So I think this gets hit, right? Like this is an optimization we're adding out. But I think quite a lot of the issues with performance is probably this. We're going into an array to get an index, which then gets the information for the sphere. So you're basically doing an indirect lookup. Like per sphere that you try and check, which could probably be quite costly. It might be good to preload 8 of them at a time and then share them and put into LDS memory, and then like, yes, it might be good to preload eight of them or whatever, or maybe 16, and then share it between this many threads. Right, 1,000 threads you're sharing it between. It might be the sensible idea. So basically, if you get here, maybe you could do like a control barrier. We should probably do like a bit of LDS memory or whatever. Share between all of our thread group. Right, so here's what I made earlier. So we're just going to get so many spheres. I don't know how many yet, but I'm just going to probably say 32. So we get the first wave, and that will... you'll get the first wave. You'll get a wave index, maybe. Wait, is that even a way? Is there a way to do that? No, you can only get a lane index. You get a wave index, probably. So we should probably preload the spheres. Right, so we can say, like... preloaded spheres or whatever. Maybe there's like 32 of them. So let's see if we can get a bit of performance gain doing something like this, where you say if your SV dispatch group, not really the group index, but maybe the local index dot x. Let's say there's 32 by 32. That's another point as well, probably. I guess if you're the first 32. The y equals 0. So we're just going to preload like into there from should do the indirect lookup. And you kind of want to say so long as if this, oh my days, that many of those, yeah, is less than spheres count, something like that. So you'll just chuck that in there. So you're preloading those. So the first wave of all of those threads in the thread group preloads 32 of them, if there is 32. Yep. And then it'll wait here for all of them to get here, and then it'll go on. Now the optimization that we're going to do is just say, okay, so it's just a quick test to see if it actually works. And we can clean up the code later if it is a really good idea or not. Because the problem is you're now saying, hey, load 32 of them. Maybe none of them actually do need 32 spheres to look at, right? Maybe it's a bit too much of a higher number. But yes, the idea is basically if sphere index is 32 or less, we'll grab it from LDS memory. If not, we grab it from... And maybe this isn't a good test having a branch here of an else statement. Right, but... hey. We've got to try things out. GFX CS preloaded spheres. Sphere index. Right, so let's try that out. What? Oops. Alright, so let's see how that goes. Hopefully the stream doesn't crash. Let's see, let's go. Alright, we're still going. So we should be loading from those. So we've got about 7 milliseconds there. About 5.5 milliseconds on the, yeah. Right, so about 5.5 milliseconds. So, on that ray tracer, I forgot what I was doing before. What number was that? 800 odd. Right, I don't know if it actually got any better, to be fair. Let's undo what we just did. Let's try that. Again. Boom. Right, it's about 5 milliseconds there. I don't know if it actually was an increase. No, that's only 600,000 odd. Bum bum ba da bum. Seems like we're pretty close to. Right, about 800,000. Yes, it's probably a bit better, but not massive better. So I think we probably helped out some things, but not all of them. So yeah, there could have been many issues with that approach, but yeah, it wasn't massively better. This is probably a big killer with the technique. See, I don't know if you can cram. You can't cram into a 32-bit integer the context of a sphere, unfortunately. It's just too much. You've got center position, right? Which alone, you could probably just about cram into 32 inch. So then you got like a radius, right? And maybe you want to make these ellipsoids there, then you got a color in there. So they do need to be. See, unless we make the sorting code, unless after we sort, we take all of the binned indices and we make a contiguous array of spheres, and then it means that maybe we take it, make a contiguous array of spheres specifically for these binned entries, and then maybe. But then I don't know. So you're paying the cost to read and then write the data out, but you're only doing that for every entry, right? Whereas this thing is doing it. What is it doing it for? It's doing it for. Is it doing it? It's not doing it for every pixel in the tile, because it should be putting it into cache, and it should be running on the same compute unit. So it should be cached after that. But maybe it does. Maybe it's something worth trying out and see if it does make a difference. Other than that, you've got this sort of anti-aliasing. I guess we could turn off the anti-aliasing and just see like how much that helps. So now we're not any anti-alias spheres, and you can tell how ugly these things look now. They're really bad. Look damn ugly. But yeah, let's just get to good camera position. Right, that's probably about what we're looking at. So that was what? It's about 800,000. Performance-wise, 5 milliseconds. It's not so bad there. Doing the anti-aliasing, disabling that. It's about, well, it was about 5.7, wasn't it? So it's quite a negligible cost by the looks of it to add the anti-aliasing on, which is fine. Seems quite negligible. I guess. So I wonder where the cost is. Should we see if we can try this out? We're gonna put a cursor over a tile, and we're just gonna see how many spheres are in that tile. Just to get a gauge of like what's Man, those spheres look way better with the anti-aliasing. Does it really? I'll take that as a compliment. Thank you. Oh, what a G. Right, so we hovering over these. I don't know. I should have paused it. I just picked a random one. 500 spheres. We can see where a lot of the cost is happening then. Maybe the tiles are just too big. So it's got to, like, your arrays, like, so the reason why I did 32 by 32 is because then I had less tiles, which became, the only time it became a problem is when I had to bitpack into the sort keys array. I had to bitpack into the sort keys, and I wanted 20 bits for depth, so I could do a fixed point 1010. So we got 1024 integer bits and 1024 fractional bits. But if we decrease it to maybe we can decrease if we have 18 bits of depth, right, take 2 away, we should be able to have 16, that'd be 14 bits. That's 16, sorry, 1,000 tiles. So given like a 1080p screen or something like that, if we divide 1920 by 16, that's 120. So let's times that by, let's square it, 14,000. So if we reduce it down to 16 by 16, I think we're going to get a better number there. So let's try that out. I think we're going to reduce the amount of, it's not going to half it, the amount of entries. It's probably going to do about a 1.5 decrease. But you might get more spheres in more tiles though. Yeah, so something to play about with. So let's make it 16 instead. And then let's right, I did some shifts and I did some hard-coded values, but here we go. 18. Let me do some shift rights. 20. Let's fix those. 18, 18, 18. Alright. So we don't want fixed point 1010 anymore, we want fixed point 108. So that's 256 fractionals. Sorry. yeah, so the bit after the decimal place, we've got 256 possible values. So that's the smallest unit. That's the increment that we go up in a fixed point. There's 256 of those to get to 1. So maybe it's enough. Yeah, but we might get some stuff. I don't know. So we change that to 8. What is this saying? 20 bits, right? So 2 bits off, so that'd be a 7. Sorry, it's not 7. No, 3. Right, 7's the Alright, 3. We want the 1 and the 2 bit. Right, let's give that a go. Hopefully we don't blow up the computer, but we'll see. Right, here we go. Right, so we're seeing some glitches now. We're missing... I don't know, was this always there? Right, the performance is way better. Oh, it is. But I'm clearly missing gaps. I'm clearly missing gaps here. But that was 800,000 there, and we hovered it. There's 216 instead of 500 odd. So I think, yeah, that definitely does help with the performance. Doing that change. Although, why the crap when we change the number of... Should we go back to 1 instance? Yeah, let's go back to 1 instance and see if we're getting those sort of glitches. And then we can, I guess, scale up the instances some more and just see what we... Right, so I'm not getting any whole clusters disappearing, that's fine. We can ignore these glitches, this is the occlusion buffer. Bom, 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 bom. Right, that's cool. That's cool. So... Man, it's pretty quick. That's under a millisecond for that ray tracer there. So it looks like 16 by 16 is a sweet spot. I guess as it gets smaller, the find starts fill gaps takes longer for some reason. Right, there's now more tiles. Yeah, there's way more tiles. There's 4 times the amount of tiles. So these shaders here, well, this shader takes a bit longer. Yeah, that one will have to go optimized, but that's not so bad. I'm more interested about this one really. Okay. So shall we up it to a 4x4x4 set of spheres? Although we're kind of like getting to the point now where we're filling up our million sphere cap. So how how we fix that problem? We up it to 2 million. So what's a good 2 million number? That one. So this number is also the number of max sort entries. Should probably keep that the same, to be honest. Maybe we should just take that and make it spheres cap. Alright. So, okay, here we go. So we try this now. We should be able to see 2 million spheres on the screen before it caps out. So again, each one of these balls is 1.6 million spheres. We've got 4 by 4 by 4 of them, so that's 16. Right, mass. And some of them are off screen there, it's a bit... my camera is just so bad. But yeah, so we're about 4 milliseconds there. 5 milliseconds. To ray trace there. Bearing in mind, I don't know how much better... Right, this is 2 milliseconds. If I do all of those, it becomes like 5. So I wonder, let me change the LEDs, so let's pop that back. So there's the low level of detail. That's brought it down to about 2 milliseconds. So I would have thought we would have been culling. I think a lot of the problem is this, they're kind of sub-pixel, right, at this LED, at the highest LED, they're kind of sub-pixel here. So maybe we've got to be more intelligent with how we and obviously you can see the grid pattern because there's some glitch somewhere, of course. But anyway. Oh. Whatever. But as you can tell, these spheres are kind of like sub-pixel. Like, oh, you know what it could be? No, I was thinking it could be the anti-aliasing. Yeah, the anti-aliasing, maybe it could be. Maybe not. But yeah, so I don't think we should anti-alias when the spheres are like basically sub-pixel. Like, there've got to be a couple of pixels. At least anti-alias. That's something to do. But yeah, maybe I should disable the anti-aliasing and see if we get this sort of grid cell pattern. But the but yeah, that's interesting that we probably need to select the level of detail better. And then maybe stuff like this won't be so bad. Although this is quite noticeable when you change it, right? So what I'm thinking is, why don't we put some proper lighting stuff down? And then we can see this LOD change and see if it's actually noticeable when you have maybe some proper lighting. Again, I've got some like I got some basic lighting, right? So I got a light coming down from above, kind of above, and we're doing this sort of like normal of the sphere dotted with the light. So this just does the normal. This one does the packing, just the raw color. This one does the color multiplied with the color multiplied with the how much the light intensity is. So if we try that, we should get some better. Right, here we go. So yeah, should I disable the anti-aliasing for a minute? And also, where's this damn... We should see dark side. Is this in like view space instead of what, like... Is my normal just off? No, the normal was max 0. Should be returning that one. Right, we saw the normal. Like it's not rotating with it. So is the normal rotating with the camera? Yeah, it's rotating with the camera. So have we gone and done like a what normal? Have we checked on like a view normal? In view space, isn't it? Um. Yeah. In view space. So where's the view from world? Vector. No, world from view. So I need to do that on the anti-aliased normal as well. It's here. I think that will fix it. No? Come on. What crap is going on? Let's re-enable that one. We should see it rotating now. Yeah, the blue over here. And red upside down, right? Yeah, good. So they changed color now. So, as we were saying, negatives are going down. Probably a bit of a slant. Let's do it directly down. Underneath is definitely a little bit darker, I can say that. Wait. Holy crap. That looks cool, but it's wrong. Like a whole... They're like transparent now. Whoopsie. So that was the problem. So what did I go and do? Oh, I multiplied... Right, I even did the alpha channel like a melon. Right, yeah, so the problem was we kept... Basically, we should be doing like an XYZ, and then we can... So we should be saying like... C... And then doing probably like... Multiply 3, C, XYZ, and then reconstruct... Wait. C.xyz. So I got swizzling in my custom compiler, which is kind of useful for stuff like this. So we can store just the swizzle components, just as a subset of the components basically, which is quite nice. So you can multiply just the color, the RGB part of that, which is super good. So now the alpha's not getting changed and it won't become see-through. So that was our first view of transparent pixels, by the way. So as we saw, it was working, kinda. But I think the outlines we're seeing is because of the anti-aliasing. So if we see here, what's actually not happening is the alpha's just being set. That is wrong. What it should be doing is multiplying, right, and merging the two together. So that was the reason why Uh, maybe. Maybe that's the sole reason why. I don't know. We're seeing them still. It's just the outline of the pixels. Yeah, there's a dark side now to the spheres. I don't know why. Right, yeah. I think that's the nuclear plane though. But yeah. So anyway, as I was trying to test out before, is if you give them like a solid color or something like that. That's so glitchy. And you change the right, you do see, so this is like the minimum height of the cluster before we change the LOD of the cluster. And what you see is they clearly right, it's not too visible, the ones at the back. Probably 12 might be alright. Maybe. But yeah, like I was trying to see if you had like some proper lighting, if you will. And this still feels a bit wrong. I don't know what's up. And I can't test it when I move the camera, which sucks. But I was trying to test if you change. Yeah, the more you change this parameter, basically, the quicker it gets. So yeah, maybe, like if we go with this method, maybe the solution is to literally just use lower level of detailed things, which could be alright. I'm just seeing how detailed we can go. Yeah, 128 seems quite... Like, the issue we're dealing with as well is this pop-in. Like, you clearly see the change. And why is it becoming more red? Like, because... Right, because the bright part... So the bright part becomes bigger, right? So you see the light... yeah, so you see, like... Yes, the bright part becomes bigger. So maybe with the smaller spheres you sort of mess with the normal a bit somehow. Just make it kind of... Yeah, maybe you... do something. Where you use like a... Based on the LOD, you say, hey... You basically have a dot product, right? So maybe you say... You use the fact where if it's... maybe you multiply the number by the inverse of the LOD or something like that. And maybe it could work. Maybe it can just make them brighter, and therefore you won't see this brightness change. And maybe that fixes the problem. That pop-in is a bit sad. But then maybe you can have a bit more of a conservative LOD selection. So you end up bringing this performance down. Um, but yeah, it's definitely noticeable as you go around. So something to think about how we could fix that. But yeah, let's disable the anti-aliasing and just see, like, is that the cause of this tile sort of image that we see the tiles? Now we still see the tiles, right? You can see them. in the image. You see them everywhere through the spheres, which ain't good. Let's not do the anti-aliasing. I wonder what happens on the edge where the tile is. Could it be maybe where you sort of select the prepare? Hey there, Big. Hey there, Big Al. How's it going? How's it been going? Could it be anything to do with this sort of clamping strategy? Not really, maybe. Rounds down. The nearest tile rounds up. The nearest tile. Yeah. Bit confused about that, to be fair. But yeah, I think this is good though. Able to put multiple instances down. I'm not sure where I want to go next. Like, we could try and because that's over 2 million spheres it's trying to put down. Like, why? It should be using a lower LOD, definitely. Right? So 12 would mean that's 3 pixels per... That's 12 pixels per... sphere. Sorry. 3 pixels per sphere because it's 12 divided by 4. Roughly. Yeah, but like... Yeah, it's about 2 milliseconds there because it's so damn small. And as we go in... So, wait, it's 2 milliseconds on the fill gaps. Whoops. Right, that shade needs to get fixed. But yeah, the sphere ray tracer. That one, about 2 milliseconds now. Now 4 milliseconds. Kind of flickering there a bit. But we're literally able to read. Now I guess that's the reason why. We're able to read over 2 million entries there just fine. But what happens if we read and wrote some of the spheres? So we've not got this indirection. Maybe this is something I want to try next stream. We have this indirection here, which happens per pixel, but it should be cached. But yeah, I want to see if we can reorder this volume spheres to render. Or maybe not even reorder. Write a new array. And would that help? You've been 2 million entries though. Be about 16 megabytes of memory that just get moved around. And it's not necessarily, it's gonna be cache miss city as well. Yeah. Maybe it'll be alright. So I reckon I want to try that and see if we can improve the performance of that when you get tons of spheres. And I guess we can think about some other things as well. There's some general ways we can improve this some more. Maybe looking to how we can reduce this sort of like Wait, I want to aim for 12. Min height on a cluster 12 pixels before it changes LOD. Yeah. So as we move, we'll get this sort of like, let's turn off the reproject. Nah, you need that. Is that the LOD change you're seeing there? Yeah, I saw it at the front. So yeah, we're trying to fix that problem. We got some interesting ideas with the normal of the sphere. When we do the n.l, maybe we can fudge some result there, I think, and see if that helps. But yeah, that's the stuff I'll probably be doing next stream, unless I think of something else. But yeah, I'll put this code up on the GitLab for those who are supporting the channel. Can get access to that. But yeah, thank you for coming, everybody. Let's find someone to raid. Our next be on Sunday at 6 p.m. GMT +1. Sometime about then. Let's see if we can find somebody quickly. Someone sensible, you know? Some sensible person. Right, I don't see no C. Eh. Right, I guess no one exists. Right, so I guess I'll just bail then. Okay, so see you all hopefully on Sunday. If I don't see you then, have a great weekend, and I'll see you all in a future one. Right. Catch you later, guys.